Welcome. My name is Sune. If you're here for the talk on containerizing MLOps within Jupyter, you're in the right place. I'm here with my colleague Richard.
Hello, my name is Richard.
If you pay attention to the catalog, you will likely see that there's 3 people that were supposed to be here, but one of our colleagues, Subo, had the very nice idea of spawning a baby a couple of days ago. So he has better things to do than being here. So instead, you'll just be left with Richard and I. We are part of a Danish company called Automatics. We do 2 things. We do consultancy and we do data science software development. We operate a number of projects with larger clients. We've been working in the space of applied machine learning for about 5 years. We've run numerous projects of productionizing data science all the way to sort of supporting it and so on. We have developed a data science platform that's called JupyterLab. That's not the content of the talk today. Instead, we're here to talk about a MLOps framework that we have developed with 2 of our customers as consulting engagements. And the purpose of those consulting engagements were to enable their data scientists to be productive in making machine learning models available within their organization. And that's what the rest of the talk is going to be about. So when you have the problem of productionizing data science, it is quite a daunting task to get all the way to the pinnacle of having a deployed machine learning model. Yeah, question? Yeah, good point. Thank you. And there are multiple ways of getting to that goal. They're not easy, any of them, but you can take a more difficult route or a slightly less difficult route. So scaling the rough side of Half Dome is something that is quite dangerous. It's something that requires a lot of knowledge and a lot of preparation, and it's not something that is for everybody. What we have been focusing on is trying to put in the guardrails that will make it more accessible to reach the peak of the mountain. The view from up there is equally good, no matter if you take the easier way up or the hard way up. But putting in the guardrails, preparing the route up to the mountain, that makes it accessible to more people. That is sort of the main challenge, and that's what this problem or the project that we have been carried out with a few of our customers have been about. We're in the process of open sourcing the framework that we're going to show you. It's a process that is underway. We're working with some large corporate clients, so the process is taking a little bit more time. We had hoped that we could get it open sourced and launched in connection with JupyterCon, but if you're interested, come see us after the talk, come to our booth. We can note down your email address, and then we can let you know when we can start to share the source code behind all of this. The traditional way of developing a machine learning model and then putting it into production is usually something that is somewhat challenging, and you can visualize it in a way like this, where business interact through a use case with the data scientist. They have a particular flow, a preferred way of building the models. They're training it. That's what the guy on the treadmill is signifying. And then usually they're handing over the trained model to some type of production engineer. And that production engineer is usually in charge of interacting with IT and making sure that they get the certificate, server provisioning, and then putting the model into production. But there's a bunch of issues with this. So what we set out to do was to reduce the time spent in this process where you interact with these roles and reduce the friction between the different roles. Additionally, we wanted to enable the data scientists to work in a way that was natural for them, where they're still feel productive and where everything is running almost as if they're just running in JupyterLab all of the time. We want them to be guided in following best practices in terms of building the model, deploying the model, and then we wanted to simplify the development, also mainly the deployment process. And lastly, we wanted to ensure consistency between the model training environment and the production environment, because that is crucial. You can get into situations where if you train your model in one environment, you are productionizing it in a different environment, the predictions can no longer be trusted. There are various things in your environment, different versions of different packages, operating systems, etc., that might mean that the model that you could trust in development is no longer providing the same output results in production as it did in development, given the same input. So that is something that could mean that the organization is making the wrong decisions based on the same input data that they see in before. So what we want to achieve is something that is more exemplified by this. You have a closer collaboration between just the data scientist and line of business. The data scientists are in principle collecting and connecting their machine learning model in the context of Jupyter still, but inside of Docker containers, which then becomes the production environment, and the machine learning model gets trained in a production setting in the environment in which it will always also be deployed. The way it looks overall, the result of this is like this. So you have the blue box around it is like the deployment environment. We're using Kubernetes for this. You could use a local server if it's beefy enough and has Docker. And then the orange box is everything that happens within Jupyter. And that's what was important for us, to keep the data scientists in the environment that they know well. Kicking off the process, helping them with using a Streamlit app to kick off a cookie cutter that helped them get a version of a source code that is sort of the basics for developing the machine learning model, ensuring that they should only focus on a couple of things, namely a file called model.py, etl.py, and their environment. And then as things progress from there, everything is handled by the framework. They're put into the right environment, with being a containerized Jupyter kernel that gets updated automatically. My colleague Richard will take you through the details of how that looks.
All right, very well. Thank you, Sune. So I'm going to go a little bit into detail of how exactly we approach this, but I'm going to talk about some technologies. So can you just, by raising your hand, who has heard of Docker and know what Docker is? All right, very, very good. And now how about MLFlow? Okay. But it seems like most people know what these technologies are. And MLFlow, if I saw a little bit less hands-on MLFlow. So MLFlow is sort of is a really nice service that allows you to track models, or it's very good for tracking models automatically. So whenever you run your training procedure, you get all the tracking automatically for you. So in order to introduce you to this framework, I think it's better to go through the standard data science workflow that you usually see in the business. And that is usually a business comes with a use case. And in this case, it can be a use case of image classification. Let's go with that. That's pretty common. And then when the data scientist gets this, then it sets up its basic tools, usually Python with poetry as a setup as a virtual environment. And that's all great and fine. And then if you go into the deeper, then you want to start training a specific model. Might be some Hugging Face or TensorFlow or PyTorch, that's fine. But you go ahead and install the tools that you want. And then you finally get into your notebook and start creating the model. And then when you start to try to create the model, you realize, I actually need the images. And the images lie in S3. So let me just quickly pip install Boto3. All right, no problem. Now I have Boto3, I can fetch my images, and then you realize, but I don't have metadata for these images. They actually lie in this Postgres database right around the corner. Okay, no problem. I'll just do pip install scopg2, and then I have the tools to get the metadata and get a better model. And this is what's happening, and you iterate, and you iterate, and you create an environment which has all the packages that you need, and you finally get to a model that you're happy with, and that has had great performance, and that's great. All right, what's the next step? Let's put it into production. And this is something we call the production nightmare, because then you come with this artifact of the model to the engineer and tell him, please put this into production. And the engineer comes back, okay, so what are the package versions you've used? Okay, all right. Well, I did some pip install here, pip install. Maybe I can just do pip freeze and explain, maybe not, maybe that's not enough. But you have to go back and figure out what are the exact package versions that you've used. And you give it back to the engineer. And the engineer is like, these packages they're not compatible. It's not going to work. It doesn't. This is not exactly what our server can provide. Like you have to downgrade this pandas version because this is because we can't support this and yada yada. You know the drill. This is sort of the common case that happens. So okay, you go back, you refine your packages that support the production server, and then the engineer comes back and okay, what about the security? Like these packages are not secure enough. They don't go through our security services. So then, 2,000 years later, you finally get the model into production, and that's great, and you're happy. But the business, meanwhile, died, and they are not happy at all at the agility that you provided this model with. So this is a problem. How can we resolve this? Is it even possible to resolve this? Well, and that's exactly what our framework is trying to accommodate. And our idea is that you use container technology. And we believe that container technology is the right step in the direction. It's not quite the full picture. And what do I mean by this? That this workflow that we've presented here, we like this workflow. This is how data scientists work. This is where data scientists are happy. It gives them agility, and they can create whatever model they want. But it just doesn't go well when you want to scale it up to production. So what can we do? We can introduce our blue whale friend, which I'm going to call Moby for the sake of this talk. And he's going to have a partner in crime, MLFlow. And now we're going to feed this workflow to them. So what do I mean by that exactly? At each step, wherever each step is going to be preserved, it's the same. But instead of just creating your virtual environment manually, we will use our blue friend Moby to help us start from a base image, which has all the necessary things already installed. Great. And when I install packages, our friend Moby is there watching us. What have you done? What have you changed? Snapshot it and store it as well. So that every time you change your environment is stored and safe-kept. And the same goes when you start iterate and training the model. Then the partner in crime MLFlow is going to know, it's this model. We have all the artifacts, you have all the parameters, and you also have a pointer to our friend Moby, which says, it's actually this image was used to train this model as well. And this way you keep both the environment and the artifacts together linked. And the same then goes to productionize this. It's very simple. You already have the Docker image, a stable environment, and you have the artifact, you put it together, and you deploy it. So this is how it sounds in theory. How does it actually look in practice? And for that, we start to show. So first, we go to this cookie cutting template. And this cookie cutter contains all the source files, as Sune mentioned before. And now we start this streaming application, which is a front end for the cookie cutter. What we're using here, we're using Voila together with Jupyter Server Proxy to start a streaming application. It's a really cool trick. If you don't know about it, it's not the point of this talk, but this is how you can actually start any application in Jupyter. And here, I'll just specify where the files should be located for my particular project. And the rest is actually just cookie cutter parameters that you get. And this is very generalizable. It can be used for any cookie cutting Git repository whatsoever. So project name, description, and then in the image, there are some pre-built images in here, which have all of the standard frameworks. For this, I just used scikit-learn because that is the most common one. But this is sort of where our friend Moby is already helping us and giving us an environment with the tools that we need and we want to use. And then we just specify the experiment name. That's for MLFlow. Click on Create Project. Cookie Cutter does its job. And there we go. We have a project done. We can click the link. And we get into JupyterLab with all the files already present. We start with a really nice notebook. That's Alfred Subu did. And it's very, very visual and very easy to follow. But we also get all the files including in it. So it's not some hidden library that you don't know how to use. You can always go to the source code and see what is actually going on beneath the hood if you want to. And this is how you start a project. So now, how does it, how about when we start to train some models? How does that look like? So instead of this getting started notebook, we have the workflow notebook. And this, as you can see, is using a specific kernel. And this kernel is already running in the Docker container. So it's already separated from the environment, and it has all the things that you need to start with. And then here are the files. So we start importing importing all the files that we have there. I'm going to skip ETL for this talk because that's a separate story, and let's go straight to the training. And in the training part, we have some parameters. So where do they come from, or where do they go to? In the steps folder, we have a model.py, and here is where our model is defined. And it's a simple pipeline here, which is a single step of a model and nothing else. And it has some parameter coming from configuration. And this configuration can be then passed directly by invoking the MLFlow run command in here, right over there. And then it has also a Kubernetes configuration. I'll touch upon that later. But when we execute this cell, the first thing that happens right away is our friend Moby saying, building Docker image. So right now, it is capturing exactly the image that you're running. So whatever your pip installed, or poetry edit, or done something, or even apt-get installed in here, it's going to take it, snapshot it, and put it into a registry. And that's your environment that's going to be the model trained in. So then, when we have the image is published in the registry, and then a Kubernetes job starts, which is the training job, actually. And then the job itself is pretty simple. It's just run the training of the model, and the model is logged in MLFlow together with the actual image SHA-256 pointing to the environment that you start with. And this is all happening underneath the hood. And so it seems like, oh, it's just training. It's actually training in a different pod, maybe in a different machine or something, because it's a Kubernetes job. But all of it is logged, all of it is reproducible, and you can always recreate the exact same training, the exact same parameters, and the exact same results at every time. And there we go. At the end, we actually have the artifact in MLFlow pointing to the Docker image. So what does that mean for our example we started with? How can we use this to put this into production? Well, that's actually very simple. We've created another Streamlit app for that. Let's just have a look. It's called Model Deployer. And once again, we're going to use the same trick as before, using Voila together with Jupyter Proxy to start a Streamlit application. Very cool trick. Please ask me about it if you want to. I really like that trick. And all right, now this is another simple Streamlit app coded in just a few days. And we go with a couple of options for deployment management, but let's go with new deployment. Now I choose the MLFlow experiment name, specific run ID, and then let's give some description to the deployment, and let's just click deploy. Now it's pointing to a specific MLFlow run ID, and that knows what the artifact is, which is pointing to the right image. All right, it's deployed. Let's go to there, and we have a simple fast API serving the model right away, and it's the exact same environment the model was trained in. So we know the results are going to be exactly the same that we saw when we were training it. The metadata of what the input is automatically detected as well, and we get the result when we query it. And my main point about all of this is all we have used was Jupyter ecosystem, Kubernetes, MLFlow, and container technology. And all of these are open source. So you can essentially just use all the tools which are already available and create, and instead of like having these vast options when you're climbing the mountain, you can just narrow it down using these technologies and make it easier to climb the actual mountain and get to the same result that you want in a safe and a guardrail manner. All right.
Yeah, so that sort of brings us back to where we started, the diagram. So for us, it's about making sure that the data scientists feel comfortable in that environment, putting in the guardrails to ensure that they can easily follow best practice, making sure that the barriers for deploying and for being able to trust the model once it is deployed has been sort of lowered as far as possible, so that you can get to this iterative process of developing a good model and do it over and over again. So if some of you work in large organizations, don't do one-off developments, deployments every time. It's time-consuming. They're harder to maintain as well. The good part about having a corporate MLOps framework is that it's easier for other people to also maintain and retrain your model and so on. So basically you can just retrain a model because it was done within a Jupyter environment by scheduling the notebook that does all your retraining, pushing the new version, etc. So you simply just need to go in and redo the deployment overall. Yeah, so that sort of concludes the talk. We are outside in a booth out here, but we unfortunately do not have time to go into some of the technical details in a talk like this. But if you're a data engineer or a data scientist, these would be good things to come talk to us about. We are just outside here with our colleagues, so you're welcome during the conference or afterwards. Happy to reach out. If you're interested in some of the code base, we have both for going from the cookie cutter to a Streamlit app as one library, and then the whole MLOps framework being outsourced or open sourced at one point. Then let us know, and we can write you an email once it is available. I think we'll open to questions.
Okay, so the question was, I mentioned the security audit issue, and how does this framework essentially resolve this issue? Well, the only way that it doesn't completely resolve it, no, but it can definitely help, because most of the Docker images, when they are published to a registry, they have the scanners in there, and which scan for all the security vulnerabilities. And that's something usually that, at least for the tool we use for registry, which is Harbor, it has this functionality as well. So that means that if you look at the model and what the image is pointing to, you can exactly see what security vulnerabilities it contains. And if it's a problem, then you have to essentially redo it again with the vulnerabilities removed. Yeah.
The requirements file is in there as part of the cookie cutter when you get the version of the library. It is not sort of a be-all, end-all MLOps framework with tracking and so on, but it is mostly put in place to guide the data scientists through the process. So of course there's definitely room for improvement around this. The CI/CD pipeline part of the question, I think that could easily be added on if you wanted to use that for retraining or dependency checking, or having something that where you wanted to check something when stuff was changed in connection with a redeployment or something. But it's not something we've had the time to develop as part of the project.
Yeah, I can take it. So the question was whether there are some, whether these steps are completely fixed, or is there some availability or agility? And there is definitely a lot of availability what you can do. Still, let's remember that we have to put something into the framework. Otherwise, if you get out of the framework, then you kind of lose all of these abilities. But within the framework, you can essentially you can do whatever you want in the same way. And the whole, we really hope that the open sourcing part is going to help us to make it even more available to others, because right now it is a lot for our use cases that we usually work with. But we get more people into contributing, then they will make it easier to include more and more frameworks in there quite easily. But yeah.
So it's not a dogmatic framework in the sense that we do allow for data science freedom to operate. There is the ability to go in and define your model as a machine learning pipeline. That's sort of the example that you get in the cookie cutter when you just start out, but you are free to do whatever as long as you implement things in Python functions. And yeah, so there's some flexibility, and you can develop like interpretability models on top, SHAP values, for instance, and you are free to customize the API of the model as part of the development process as well, so that you get like multi endpoints in the deployed model. Yeah, so to take the first question about what the use of MLFlow is. So we use it twofold. One is for tracking the experiments as the data scientist experiments over time to see and track performance, to be able to give them the ability to select the best performing model. But then once you're done with that, you've found the right model, then we use all the logging functionality of MLFlow and the way that it can sort of stamp out unique identifiers on both defining the version of the data set that went in, the exact version of the code that resulted in that model, and referring back to the exact image identifier in the registry. So we sort of use it for those two purposes. Then the second question was sort of the type of model that the framework was supposed to be supporting. The initial example that people get is sort of for tabular data, but we have had use cases of it for image data as well. It depends on the execution environment. If you need to do like deep learning, you probably need to do some customization in order to spin off training at scale across multiple instances. This is sort of depending on training within a single Docker instance for now. Want to add to that, or?
Not really. Like we definitely support scikit-learn models, TensorFlow models, PyTorch models. These are all supported because they've been requested. I'm sorry, didn't quite hear it.
Using something else than Kubernetes for orchestrating the container execution.
Right. Yeah, you can absolutely do that. For us, Kubernetes is just the execution engine here that we started with, but it is completely extensible to other different orchestration engines. Okay, so the question is if the production environment we want it to be different or leaner, whether it's essentially possible. And right now, not quite. You would have to do something manually to achieve this. But we kind of like, we go a little bit against this. Because we really put emphasis on having the training and production environment to be the same, such that you can trust the predictions you get out of the model. Because the moment you start changing the environment that you train your model in, some question marks, at least in my head, rise. If you change one version of pandas or of some particular transformer, and then suddenly a float turns into an integer, things can get not nice for the model predictions. So that's why we always try to say size doesn't matter, or if it's fast enough, it's okay. Then you can always optimize the image itself to be faster, such that the responses are speedier. But try to keep the environments the same in production as in training. But that would be my answer.
Any last question? No? Okay. I think lunch is the next thing on the agenda then for everybody. Enjoy. Thank you.